Hello, good evening, everyone, and welcome. Thank you for coming to Imperial Lates Online, the latest in our event series for adults exploring research here at Imperial College London. Across this week, we've been exploring a theme with our very own researchers, and this week has been all about the sun. This is the Imperial Lates Online Pub-less quiz, and this is the Sunshine edition. My name is Maeve, and I work in the public engagement team at Imperial, and tonight I shall be your Quizmaster. We are joined tonight by Imperial researchers Brian and Reshma, who look at hydrogen as a renewable source of energy. Hey guys, we're going to have more from them a bit later on, so see you later. But first, I'm going to explain how the quiz is going to work. This is my lovely slideshow. So you'll need a pen and paper or something to write something down. Maybe you like to write things on your phone or on your laptop, either is fine, but pen and paper is the best image I could find for this. There'll be 4 rounds. So we've got round 1, which will be a general knowledge round. Then round 2 is our researcher round, where we'll bring Brian and Reshma back to deliver questions that they have written, centered around their research. We will then have a demo and Q&A. So that's going to be for about 10-15 minutes in the middle, where we're going to have Brian from the lab showing us a little experiment, and we'll have a chance to ask a few questions to them as well. Then we have round 3, which is a wild card round, which is a little bit left field of things about the sun. Then there will be a link posted in the YouTube chat, which should just be over there, and you will click on that to submit your scores. So as we go through each round, we'll do the answers, keep a track of your score, and then when you click on this link, you put the scores in, and then you use that form to do your answers for the speed round, which is very fast and at the very, very end. So I have some rules for this quiz. No correct answers in the chat. So just imagine you're at a pub with your mates. You wouldn't be shouting out the correct answers or writing them on the wall. So don't put them in the chat, otherwise everyone will know what the answer is. No cheating, please. I mean, I won't know if you do, but it's much more fun if you don't cheat and you spend time talking to your friends and family thinking, what is the answer to that? There's also no prize, so it's, you know, it's not recommended to cheat. Please no inappropriate or disruptive use of the chat. I have Emma, my colleague in the background, who will be monitoring you. So let's all be nice and don't abuse anyone in any way. It's just a nice quiz. Do not argue with me. I'm the Quizmaster. Thank you, Patricia Lynch. Ready to quiz. Andy, let's go. Very exciting. Good. So yes, no arguing with me. I have researched my answers and I am the answer person. We also want you to get involved. So if you want to comment, let us know things like your team name in the chat. And also if you've got questions for our researchers, please ask them as well. Tell us about any silly answers you get after we've done the answers for each round, of course. And yes, pick a team name. So yes, please do let us know about that. And when my colleagues pop up little things down there, I'll be able to see what's going on, which I like. If this slide comes up, it means that we're having a bit of a problem, you know, internet, things like that. So just stay with us, maybe grab a drink, take it as a little break, but we'll let you know if anything else is happening beyond that. So that is about all I have for you there. And so I think we will just crack on with the quiz if everybody is ready to go. So this is round 1. It is general knowledge. Here we go. Question 1. Fill in the blank of this sunshiny lyric. Ain't no sunshine when she's gone. It's not, when she's away. So remember to have your piece of paper and pens and write down your answers. Keep a track. There's 1 point for every correct answer. Just keep a little tally when we do the answer at the end. Welcome, all of the teams coming in. Like seeing these team names. The Welsh Rock Hounds ready to go. So question 1 again. Fill in the blank of this sunshiny lyric. Ain't no sunshine when she's gone. It's not, when she's away. Question 2. The sun has enough nuclear fuel to shine for another 5 billion years. After that, what will it become? Will it become A, a red giant, B, a white dwarf, or C, a supernova? Welcome, Team Spice Girls. Hats off to that. That's question 2 again. The sun has enough nuclear fuel to shine for another 5 billion years. After that, what will it become? Will it be A, a red giant, B, a white dwarf, or C, a supernova? Hello, Team Sunbeam. Excellent name, very on topic. Okay, question 3. Still on our sun theme, as always. Who painted this lovely pot of sunflowers? That's question 3. Who painted this lovely pot of sunflowers? Question 4. In Western astrology, which of these signs of the zodiac is said to be ruled by the sun? Is it A, Aries, B, Leo, or C, Sagittarius? So that's question 4 again for you. In Western astrology, which of these signs of the zodiac is said to be ruled by the sun? Is it A, Aries, B, Leo, or C, Sagittarius? I always find questions about astrology quite difficult unless it's about my star sign specifically. So hopefully one of these is your star sign, or you're in a team of people with varying star signs, so you can figure out the answer. So A, Aries, B, Leo, or C, Sagittarius. One of those signs is ruled by the sun. Okay, question 5. Now let's not forget about the Chinese zodiac. So on the 12th of February this year, a new year began for which animal? Is it A, the ox, B, the rat, or C, the tiger? That's question 5. We don't want to forget the Chinese zodiac. On 12th of February this year, a new year began for which animal? Is it A, the ox, B, the rat, or C, the tiger? Question 6. The sun is really big. Approximately how many Earths could you fit inside the sun? Would it be A, 1 million, B, 50 million, or C, 1 billion. That's question 6 for you again. The sun is really big. Approximately how many Earths could you fit inside the sun? Would it be A, 1 million, B, 50 million, or C, 1 billion? Okay, question 7, bit retro now. What once popular TV show featured a baby in a sun in the sky? Here is a picture of said baby. So that's question 7. What once popular TV show featured a baby in a sun in the sky? And for reference, the baby. Okay, question 8. One of my favorite topics, Greek mythology. So in Greek mythology, who flew too close to the sun? That's question 8. In Greek mythology, who flew too close to the sun? And just to be clear, they didn't fly to the sun in this paper aeroplane as I have shown. It's just more of a suggestion rather than to be accurate. Turns out the icons on PowerPoint presentations can be quite limited. That's question 8. Who flew too close to the sun? Okay, question 9. In which film did a bunch of warriors shoot all their arrows at the sun to block it out? So I want the name of the film here. For question 9. In which film did a bunch of warriors shoot all their arrows at the sun to block it out? And finally, question 10. If the sun suddenly disappeared from existence, approximately how long would it take us to notice? Would it be A, 1.4 minutes, B, 8.3 minutes, or C, 18 minutes? So once I finish this question, I'm going to give you a couple of minutes to discuss, have a think, get your answers down, and then I'll be coming back to do the answers with you. So question 10. If the sun suddenly disappeared from existence, approximately how long would it take us to notice? Would it be A, 1.4 minutes, B, 8.3 minutes, or C, 18 minutes? Okay, everybody. So I am going to give you 2 minutes now to consult yourself if you are in a team of 1, or consult your friends and family if you're in a team of more than yourself. So I'll see you in 2 minutes. Please enjoy this royalty-free music while that happens. Something that will be very exciting to everyone who's experiencing working from home, my dog has just began barking at something. So I'm going to give you a few more minutes. I'll just be a moment. Classic working from home, guys. Thank you for your patience. I will now crack on with the answers. I hope you made the most of your time. So, while I have answers, I also have extra info. Our dog is barking at your dog. I'm so sorry. Hopefully they were just settling down for the night, but she's so cranky. Hi, Janice. The name of my dog is Rihanna, who I named, yes, after the singer, because she's so cool. Okay, more dog questions. She's a working Cocker Spaniel. If you Google those, they are so cute. I think they're one of the prettiest dogs ever, but very energetic. She's 10 and a half and still acts like a crazy dog. Okay, everyone. So I asked you to fill in the blank of this sunshiny lyric. Ain't no sunshine when she's gone. It's not warm when she's away. So give yourself 1 point if you got that. It's not warm when she's away. Please remind. Oh yes, I'll tell her not to bark out the answer. Should be in the rules. Thank you. Great. So 1 point for that. Remember, each round is out of 10. So it's 1 point for question 1. Question 2. The sun has enough nuclear fuel to shine for another 5 billion years. After that, I asked you, what will it become? So it will become a red giant. So 1 point if you got that. So a red giant is a dying star in the last stages of its stellar evolution. So it expands and it engulfs inner planets, which might even be Earth. I mean, it's a very long time away. A white dwarf, which was also one of the answers, would be the end of the sun's life. So I asked you what would be next, which would be a red giant. But after that, it would become a white dwarf. So that's when it sheds its outer layers, the core collapses, and becomes a husk of a star. And a supernova, the other answer, that will never happen to our sun, because according to scientists, it isn't big enough for that to happen. So our sun will not have a dramatic, fiery death. Question 3, I asked you, who painted this lovely pot of sunflowers? I hope you got this. Quite a famous drawing. This is Vincent van Gogh, or Gogh. I can never remember which one it's supposed to be. Vincent van Gogh. So 1 point for that. Question 3. Question 4. In Western astrology, which of these signs of the zodiac is said to be ruled by the sun? Now, I was trying to trick you a little bit because they are all fire signs, surprisingly. The answer here is Leo. Leo is ruled by the sun. So all of the signs of the zodiac has some planet or heavenly body that is said to rule it. There aren't enough planets and luminaries to go around, so some of them share. So, for example, Aries and Scorpio are both ruled by Mars. This is all very interesting for me to discover. I'm a Capricorn, so none of this relates to me. Leos are supposed to be vain, outgoing, generous, and love to be the center of attention. So the sun representing the self and the core principles of our being. So there you go. 1 point for Leo. Roar. Question 5. Yes, not to forget the Chinese zodiac. So on 12th of February this year, so quite recent, a new year began for which animal? The animal is the ox, and specifically the metal ox, which I didn't know was a thing. So last year was the year of the rat. This is the ox, the metal ox. It seems to me, after a bit of digging, that Chinese zodiac signs can be metal, water, or wood. But I am no expert. So if you're interested, you can have a little look and see which one you are. A famous metal ox is Barack Obama. What a legend. So 1 point for ox. Question 6. The sun is really big. I asked approximately how many Earths could you fit inside the sun? So these are all very big numbers. You may have gone for the highest, but it's actually just 1 million. Just a million. I was asking for an approximation. More specifically, astronomers think it's maybe 1.3 million Earths that can fit inside the sun. I did get a figure of how big the volume of the sun is, but it's a really long number, one that I can't, when you don't know if it's not billion, it's not zero, it kind of goes like that. It's like 1409272569059866000, however much that is. So 1 point for A, 1 million. So make sure you're keeping a track of these because we're going to ask you for your scores at the end of round 3. Question 7, hopefully quite a straightforward one. In what once popular TV show featured a baby and a sun in the sky? This is the Teletubbies. It will be very telling if you didn't get this right. This is sort of the background of my childhood. And I think, so the baby will be a few years younger than me now. Weird. So yes, the Teletubbies. The answer to that. Question 8. I asked, in Greek mythology, who flew too close to the sun? This was Icarus. He flew too close to the sun. This is a lovely artist's depiction of how it might have looked. So Icarus made these wings out of feathers and wax, and he flew too close to the sun, and the sun melted the wax, and he fell. There's probably a moral to the story, but I'm unclear as to what that would be. Maybe that when you try, it ends in failure? I don't think that's a good moral. Anyway, Icarus. That's question 8 answer. Question 9. In which film did a bunch of warriors shoot all their arrows at the sun to block it out? This was the film 300. Here's a still from the film here, where they're all shooting their arrows up there. I believe it was the Persians said that they were going to blot out the sun, and the Spartans said, fine, we'll just fight in the shade. There's an interesting bit of information in a book by Randall Munro, who asks if this was possible. It's not impossible, he says. He said it could be more achievable if you do it at dawn, because the sun's less high in the sky. It would be difficult to get a large number of archers into highly organized rows, shooting at the same thing, and maybe they would hit each other. His main piece of advice was don't do this, really, because even though it might look cool, you're probably not going to hit anyone. So the film 300. And finally, question 10, I want to know, if the sun suddenly disappeared from existence, how long would it take us to notice? It'd be approximately 8.3 minutes. So I had a look at light years. The sun travels at 18 million kilometers in 1 minute, and the sun is 148.36 million kilometers from Earth, if you want to check the maths. So yes, that's 8.3 minutes where we wouldn't know what was going on, and then the sun would be gone. Again, Mr. Randall Munro, who was an amazing cartoonist scientist, I'm getting one of my colleagues to put the link in the chat to this specific cartoon that he's done. He talks about what would be good if the sun disappeared. There would be risks reduced of solar flares. There would be an improved satellite service because the sun wouldn't drown out any radio signals. And we'd be able to see the sky so much clearer. There wouldn't be time zones anymore. Things would be less expensive. However, of course, we would all freeze and die. So that wouldn't actually happen. Okay, let's bring back our researchers, Reshma and Brian. Hello, Reshma and Brian. Excuse me. How are you doing?
Good, thanks.
Good. Thanks, Brian. So let's just highlight Reshma for a moment. Can you tell us a bit about who you are and what you do?
Hi, everyone. I'm Reshma. I'm currently a postdoctoral researcher joined between the Department of Material Science and Engineering and the Department of Chemistry. And my research looks at technologies that can harness solar energy and use that to produce things like chemical fuels and also different molecules that we might be interested in for industrial applications.
Amazing. Thank you, Reshma. And Brian, let's go live to the lab. Tell us a bit about who you are and what you do.
Hi, everyone. My name is Brian. I'm in my third year of my PhD studying both chemistry and physics at Imperial. And I'm looking at materials that can be used to convert renewable energy, sunlight, into fuel, into hydrogen gas. And that's by decomposing water, which is made of H2O, and extracting out hydrogen gas from that. I'm really happy to be here to help with this quiz night. I hope you have a lot of fun.
Thanks, Brian. It is a pleasure to have you both. So Brian and Reshma have written the questions for this round too, and they are the experts. So if you have any questions about any of the stuff that comes up, let us know in the chat. The questions will be patched through to me, and I will ask them directly to Reshma and Brian. So let us kick off with, I'm just going to leave this to you guys. So Reshma and Brian, take it away.
Okay, thanks, Maeve. So the first question of this round, let's start with the very basics. What form of energy do we get from the sun? Is it A, heat, B, light, or C, both heat and light? So question 1, what form of energy do we get from the sun? Is it A, heat, B, light, or C, both heat and light?
Question 2. The sun is pretty powerful. Every hour, the amount of solar energy that hits the Earth can power all of human society for more than, is it A, an hour, B, a day, C, a month, or D, a year? Question 2 again. Every hour, the amount of solar energy from the sun that hits the Earth could power all of human society for more than an hour, a day, C, a month, or is it D, a year?
Question 3. I use the word photovoltaic a lot in my research. Can you tell me what that means? Is it A, sun-powered, B, light cells, C, light electricity, or D, solar energy? So question 3, what does the word photovoltaic mean? A, sun-powered, B, light cells, C, light electricity, or D, solar energy?
Question 4. A thought experiment. Imagine you have a source of light on the left, and light travels to the right and then encounters an impenetrable barrier with two gaps in it, in the green. Behind this barrier is a wall, the black line. Where on the wall, positions A, B, C, D, E, or multiple places would be the brightest? So imagine you have a source of light coming from the left, going to the right. It encounters an impenetrable barrier in the green. It has two gaps in it. And behind this barrier is a wall, that black line there. The question is, where on this wall, A, B, C, D, or E, or multiple locations would be the brightest spot?
I'll just leave that image up for a moment so you can check it out.
Okay, question 5. On an average day, at what time does electricity demand for household hit its peak? Is it A, 8 a.m., B, noon, C, 7 p.m., or D, midnight? So question 5, on an average day, at what time does electricity demand for households hit its peak? Is it A, 8 a.m., B, noon, C, 7 p.m., or D, midnight?
Question 6. There is a class of materials called semiconductors that can absorb visible light and turn it into useful electrical current, like in a solar panel. Which of these materials is a semiconductor? A, wood, B, iron, C, glass, or D, silicon? Six again. There's a class of materials called semiconductors that can absorb visible light and turn it into useful electrical current, like in a solar panel. Which of these materials is a semiconductor? Is it A, wood, B, iron, C, glass, or D, silicon?
Question 7. The Toyota Mirai is the world's first mass-produced vehicle based on hydrogen fuel cells. How far can it travel on a full tank of hydrogen fuel? Is it A, 50 miles? To give you a hint at what 50 miles is, it's the distance from Guildford to central London. Or is it B, 100 miles, approximately from Wembley to Dover? Is it C, 200 miles, from London to Leeds? Or is it D, 400 miles, from London to Scotland? Question 7. The Toyota Mirai, the world's first mass-produced vehicle based on hydrogen fuel cells, can travel what distance on a full tank of hydrogen fuel? Is it A, 50 miles from Guildford to central London? Is it B, 100 miles from Wembley to Dover? C, 200 miles from London to Leeds? Or D, 400 miles from London to Scotland?
It's good to put it into to context how far those things are, because I am just terrible with what mileage. I probably would have thought that Guildford to central London was the same as London to Leeds, so that's good. Thanks, Reshma.
Yeah.
And now for question 8. Which of these is the scientific term for the effect that moves charges in a semiconductor, like in a rooftop solar panel? Is it A, drift and diffusion? Is it B, drifting? C, inertial drift? Or D, Tokyo drift? Eight again. Which of these is the scientific term or the effect that moves charges in a semiconductor, like in a rooftop solar panel? Could it be A, drift and diffusion, B, drifting, C, inertial drift, or D, Tokyo drift?
Question 9. How long can solar panels store the energy that they capture? Is it A, 0 hours, B, 15 minutes, C, 1 hour, or D, 24 hours? So question 9 again. How long can solar panels store the energy that they capture? Is it A, 0 hours, B, 15 minutes, C, 1 hour, or D, 24 hours?
And finally, the last question, number 10. Hydrogen gas is used in fertilizer manufacturing and chemical refining processes right now. In 2018, industry used about 115 million tons of hydrogen. What weight is this the equivalent of? The equivalent of how many approximately London Eyes, for example? Could it be A, 5,000, B, 25,000, C, 55,000, or D, 180,000? And one last time, hydrogen gas is used as fertilizer for making fertilizer manufacturing, chemical refinings in the industry right now. In 2018, industry used over 115 million tons of hydrogen. The question is, what is the weight that this is equivalent to approximately in units of London Eyes? Could it be A, 500 London Eyes, 5,000 London Eyes, B, 25,000, C, 55,000, or is it D, 180,000?
Begs the question, why aren't we using London Eyes as a unit to measure everything now? Okay, thank you both. I'm going to give everyone 2 minutes now to have a think, get a drink, and we'll see you back in a couple of minutes. Okay, everybody, time is up. And now it is time for Reshma and Brian to tell you the answers. So Reshma, off you go.
Yeah. So the first question was, what form of energy do we get from the sun? And the correct answer is both heat and light. So for example, solar cells can take the light energy from the sun and convert that to electricity, but we can also harness the heat energy using solar thermal technologies, which can then kind of be used to evaporate water into steam, which can then drive a turbine. So two very different ways in which we can harness the energy from the sun.
The gift that keeps on giving.
For question 2, the sun is pretty powerful, and every hour the amount of solar energy that hits the surface of the Earth could power all of human society for more than a year. D. So that's a tremendous amount of power, and that's why most renewable energy advocates strive to capture solar energy. One, of course, large consideration is the fact that much of the Earth is covered in oceans and areas that are very sparsely populated. And so that's why researchers still need to continue their work on making more efficient solar panels and more effective ways of getting that electricity to populations or in storage. Because otherwise, we'd have to have massive sizes of solar panel fields. Still, much less than the total area of global agriculture, for example, but a very large area nonetheless.
Awesome, thanks. So yes, just to remind everyone, 1 point for each of the correct answers to these questions.
So the third question, what does the word photovoltaic mean? And it means light electricity. So the word photovoltaic comes from two separate words. The word photo is Greek for light, and volta is after the electricity pioneer Alessandro Volta. So kind of putting them together, you have light electricity. And interestingly, then photovoltaic technologies use sunlight and convert that into electricity.
For question 4, if you imagined you had a source of light on the left and light traveled to the right, encountering an impenetrable barrier with 2 gaps in it, there was a very good question from the audience about how big these gaps are. And yes, they're small, they're close together, they're not large size gaps. But if then behind this barrier is a wall, the light would actually be brightest behind part C, in the middle of the 2 gaps actually. And that's because when light is behaving in this way, it's actually a wave. And the wave, when it goes through 2 gaps, it then interacts with each other. And the wave fronts, think of them like water waves, and they create this pattern you see here, where it's brightest in the center and then has darker spots to the left and to the right, with then subsequently less bright spots going away. The wave nature of light is useful in many matters of fundamental physics, but in chemistry we are able to just use light as a power source, for example.
So question 5, the question was, on an average day, at what time does electricity demand for households hit its peak? And the correct answer is C, 7 p.m. So in the UK, the maximum electricity supply or electricity demand is between 6 and 7 p.m., which unsurprisingly coincides with the time that everyone goes home and needs all of their cooking and audio, visual, and heating equipment turned on. Now, as you can imagine, unfortunately, it's not the time when the sun shines the brightest. So there's a lot of technological development currently.
Oh no.
Don't.
Hi, Reshma. We lost you for a second there. I know that you had a power cut earlier, so your internet's probably warming up. You were telling us that there's lots of ways that are being looked at to make use of the sun's energy for this kind of time later in the day.
Question 6, there is a class of materials called semiconductors that absorb visible light and can turn it into useful electrical current, like in a solar panel. The answer to which of these materials is a semiconductor is D, silicon. And silicon is the main material made up in the solar panels that you probably see on roofs throughout the world, and most of them. The ones that are blue or black. And these can be either single crystals, giant crystals of silicon that are just cut into very thin slices and then placed on the roof, or they can be what's called amorphous. They can have little bits of crystals of silicon, and these absorb sunlight and create electrical current. They're halfway in between insulators and halfway between metals. So iron was a metal, and wood and glass were both insulators that don't allow charge to go through, but a semiconductor has properties of both, somewhere in the middle, and that's why it's useful.
So sneaky. I feel like I wasn't told that at school. It was like something is either a conductor or not a conductor. Very clever, silicon. Very clever.
Okay, so question 7. The Toyota Mirai is the world's first mass-produced vehicle based on hydrogen fuel cells. How far can it travel on a full tank of hydrogen fuel? And the correct answer is 400 miles, so all the way from London to Scotland. So a lot of reason to be optimistic here in terms of hydrogen fuel cells. They can go really far, and it takes only a couple of minutes to recharge them. So it's just a matter of getting the technology more cost effective and making it more widespread, so we have many more fueling stations in society.
Question 8. Which of these is the scientific term for the effect that moves charges in a semiconductor, such as the aforementioned rooftop solar panel? The answer is A. It's drift and diffusion. This is a combination of two factors. One is that charges want to move from an area of high concentration to lower concentration. If you don't want lots of electrons and bunch up in one place, they'll move away, and that's diffusion. Drift is how they move under the influence of an electric field. Of course, there's a property of the material it's made of, like silicon. So silicon will make a field and push it towards one direction or the other, making a current. The other options were drifting, which is to do with cars that move while their wheels are locked, I believe. Inertial drift is
It's an arcade racer. It's like a virtual car you can buy for the PlayStation.
Tokyo Drift was a film. Fast and Furious.
You're so tricksy, Brian.
So question 9 was, how long can solar panels store the energy that they capture? And the correct answer for this is 0 hours. So solar panels by themselves cannot store the energy. So we need to kind of couple them with either solar battery technologies or water electrolyzers, which is something that both Brian and I research on, and use this energy to convert water into hydrogen and store the energy as hydrogen, which we can then use either at night when the sun is not shining, or on a rainy day when we have no sunshine at all.
I was absolutely amazed by that information, Reshma, when you told me. I had no idea that it would be 0 hours. So Well done
Yeah.
to anyone who got that right.
Lastly, question 10, hydrogen gas is used now in the fertilizer manufacturing and chemical refining industries. In 2018, they used 115 million tons of hydrogen, and this is actually the equivalent of the weight of actually 55,000 London Eyes. That's a huge number. I think all four answers were huge numbers. And that's actually why our research in trying to extract hydrogen gas from water is so important. Hydrogen is used so much now, and almost 99% of this hydrogen is made from fossil fuel sources, from natural gas or coal. And to replace that with solar-powered production of hydrogen would already go a huge way to reduce our carbon emissions, notwithstanding any development in hydrogen vehicles or industrial purposes for powering boats and airplanes. And so that's why there's a huge possibility for utilization of renewable hydrogen.
That's great. Thanks so much to Reshma and Brian. So remember to add up your scores. So there was 1 point for each correct answer there. So make a note of how many you got out of 10. And now we're going to do a short Q&A, but first a little demonstration from Brian. So me and Reshma are going to disappear. You'll probably still hear my voice, but I'm going to give Brian center stage here. Okay, Brian, show us what's going on in your lab.
That's great. So I'm just going to very quickly walk different parts of the lab. These are fume hoods. That's where people do chemistry and have many different setups and experiments in them. We also have setups where we work in protected atmosphere, like in this box. Over here is a lamp, a light source where the light coming from the left, I believe. It goes through this machine that actually sets the color. And then here we have colored light. For example, green here. This is about 500 nanometers wavelength. That's the length of the wave that the light is moving at. So this machine can change the color of it, and then we can use this to test our materials to see how they react in different wavelengths of light. Most of the light from the sun is visible, and so that's very useful. The machine also can give out white light as well, and to try to replicate what the sun looks like. So in addition to using the sun's energy to turn water into hydrogen and oxygen, one can just use electricity, for example. I want to make a very quick demonstration for you. So here I have this beaker of water. It's not just any old water though. It's water with some salt in it. So the salt, I've added some salt in it to make it more conductive. That's something that makes it less resistive, something that allows current to move more freely. I used here a salt called sodium sulfate, but if you wanted to try this experiment at home, you could. A commonly found salt you could use is magnesium sulfate, and that's called Epsom salt. That's the salt in bath salts. That's the bath salt for soothing injured limbs, for example. Epsom salt, magnesium sulfate. You wouldn't want to use sodium chloride, table salt for this purpose. We're trying to split water here. I'm going to show you a very simple demonstration of water splitting just using a battery, a 9-volt battery here. Now, so don't use the table salt because the reaction that creates oxygen and hydrogen, it will react with chloride, and it's not a good thing. But Epsom salt, bath salts, for example, that will be perfectly safe. So very quickly, I'm going to put this battery into the water. Yes, that's right, into the water. Keeping it upright, that's what it makes it really easy with 9-volt battery. You can see now, immediately, water splitting, hydrogen and oxygen from these terminals of the battery. Gas is from the liquid, not from the battery itself, it's from the liquid. Now, you can see one side is less gas coming up than the other. There's less gas here, and there's more gas on that side, right? And that's because water is made of H2O. There's 2 hydrogen atoms for every oxygen atom. So on one terminal, you'll have double the amount of gas molecules coming up than the other. That's why there's more in one than the other side. If you were very patient, you could leave this for a longer period of time and be able to collect collect the gases in small containers. And then if you can then see which one is which by actually by for example having a wooden splint that's burned out, and if you put it with the oxygen gas, it would burst into flame again, for example. After this experiment, do make sure to dry off your battery completely.
I was going to say, Brian, would it be safe to use that battery now in something else?
If you've only done the experiment for a short amount of time, it's just as if you were running the battery in any piece of machinery, and it's perfectly safe to reuse again. I would say if you use it for a long period of time, it might be finished, for example, just like if you were to use it in a flashlight.
That's amazing. Thanks so much, Brian. And we put a link in the chat for you, so you can try out Brian's experiment at home if you like. So you've got a link in the chat there. So I have a question. We haven't got very long because I've written a quiz and I'm going to go through the quiz. But we do have a question that's come in from Harun S., who asks, is there a reasonable priced type of mirror or glass that reflects / permits the transmission of the vital UV waves for vitamin D production and other well-being? So I've got the question on the screen there. Reshma, is this one for you?
That's a great question. It's similar to technologies that Brian was showing, where you can have just one wavelength of light pass through a filter, or you can have like an entire UV lamp source where you could, in principle, have a certain wavelength pass through. I'm not sure it's economically viable and something that everyone would kind of have at their house at the minute. At least from our research experience, it's quite specialized kit that allows you to do that. But it might be a possibility somewhere in the future to have this in a more economic scale.
And I actually had something else for you, Reshma. I'm just wondering, how does the current cost of electricity from solar cells compare to the ones produced by fossil fuels? So is there a reason why we're using fossil fuels more, or how does that all work?
So in fact, in a lot of places, electricity from solar is cheaper than what you'd get from coal or fossil fuels. And this is because of years and decades of material science research that we've been able to drive the cost down. The main issue right now is how intermittent solar energy is. So it isn't always available. So just abandoning grid source and coal and fossil fuels and going to a supply source that isn't as predictable as we would like is quite challenging. So a lot of our research is trying to bridge that gap and kind of develop battery and electrolyzer technology so we can store the energy for a time that we need it, and kind of level out the supply and demand peaks, which don't always occur at the same time.
Yeah, that makes sense. And I think we've just got one more that might be one for Brian. So this is from Jarek, who says, do you make research about using, I don't know what this word is, perovskites to catch solar energy?
Thanks, Jarek. I think you mean perovskites, and I don't study perovskites myself, but there are researchers just down the hall, within eyesight that do study perovskite type materials. And yes, perovskites are one of the up and coming materials for solar panels. They're very efficient, but what the work that they're trying to do is trying to make perovskites that are less toxic and ones that can last for longer period of time compared to silicon, or to catch up with silicon solar cells.
So perovskite is a material. Yes?
Yep.
For the layman out
It's
there.
a material type.
Brilliant. Thank you, Brian and Reshma. So I know that was a very quick whistle-stop tour of Brian's lab. Just a few questions we got to you guys. But for the audience, if you do have a question to ask, Reshma and Brian are going to jump into the YouTube chat. So if you've got anything you'd like to ask them, they will be there. I will be continuing with the quiz, but for now, we will say goodbye on screen to our lovely researchers, Brian and Reshma, and we'll see you just at the end for a quick goodbye. So thanks very much. Okay, everybody, round 3, back to business. This round I call, hey, that's my son, brackets or daughter. So in this round, it's a picture round. I'm going to show you pictures of a celebrity's child, and I want you to tell me who the parent is. I've been very careful to pick kids who look a lot like their parents. So if you're like me and you won't have seen any of these people before, have a look at their bone structure, their eyes, their nose. You should be able to figure it out. I'll give you some clues as we go along. So pen and paper, everyone. Here we go. So subject number 1. So I want to know who is the father of this young man. So his dad is a famous actor. And when I give you 2 minutes at the end of this round, I'm going to have them all up again so you can have a look. So yes, have a look. What about the hair, the hairline, the eyebrows, the jaw? So this is number 1. I want to know who is his dad. Okay, subject number 2. This man, who does also happen to be an actor, but he also has a famous actor dad. Who is it? And for anyone who's seen Dexter, this guy here was in it. I think in might be season 4. So yes, he is an actor in his own right, but his dad is, in my opinion, one of the best actors ever. Okay, number 3, this cute little baby, who I think looks very, very like his father. Now, this baby has 2 famous parents, so you will get the point for either of those, but I think he particularly looks like his dad. So his dad is a famous musician. Who is his parent? And if these questions are just too easy for you, you can chat to Brian and Reshma in the YouTube chat, who are ready to answer all of your questions, your burning questions on solar energy. Okay, person number 4. This guy is the spitting image of his dad, who is a musician. Who is his dad? Okay, number 5. This kid has 2 famous parents, so I will accept either one of them. So this is the child of who? So it's got 2 famous actor parents. I will accept either. Okay, so we've moved on from hey, that's my son to hey, that's my daughter. So some of these are tricky because you most likely won't have seen these people before. So this is number 6. I want to know who her mother is. So her mother is a very famous actress. I would advise to look at the eyes and the nose. That is really helpful. You really have to go with your instinct on this one. So you've got to think, oh, they remind me of so and so, and that's probably the right answer. So her mum has won many awards for acting, and she's still going strong. And I will put all of these faces up when I give you your 2-minute break. Number 7. This might be a bit more niche. Her mother is a famous actress and singer, probably more for the musical theatre buffs out there. So if you know, she looks so like her mum in this picture. So yes, I'm looking for who her mum is, and she's a famous actress and singer. Okay, person number 8. This lady also has a famous mother who was an actress. I would say look at the bone structure here. The eyes, I think, are very, very similar. I think, and the nose, and the smile. She's taken after her mother here. So her mother is a famous actress. Who is her mum? Okay, person number 9. So this is the daughter of another famous actress. They are similar in almost every way, I would say. So go with your instinct on this one. Her mother is an actress and also now a producer. She's made some really great films. And the last one, number 10. So what we had in 1 to 5 was the sons who looked like their dads. Then we've had daughters who look like their mothers. And this is someone's son who looks like his mother, which I think is sometimes quite hard to tell. So this man has a famous mother who is a singer. And I believe she did star in a few films as well. And I would say that the shape of their face and their nose is identical. It's a little bit trickier, this one. But I'm pretty sure that you will have heard of all of these famous people. There's nothing super niche in there, apart from maybe the musical theatre one that I mentioned. So now I'm going to give you 2 minutes, and I'm going to put all of their faces back up on screen. No, it's a bit of a tricky round, so have a look, get your detective goggles out, and make a guess. You never know. So I will see you shortly. Hi, everybody. Okay, so we're going to crack on with these answers. Let's see how you did. So 1 point for each correctly identified parent. So this man, question 1, is the son of Jude Law. I think that they have a striking resemblance. So this is his son Rafferty. So 1 point if you got that. So Jude Law. Question 2, this is the son of Tom Hanks, who I just love. So the answer here, Tom Hanks, and that's his son Colin, who is also an actor, as I said. Look at them in their little matching outfits. So question 3, this baby is the adorable child of singer John Legend. I think they look very, very alike. And also the baby has a famous mother, which is Chrissy Teigen. So this is their son Miles. So I would accept either John Legend or Chrissy Teigen. There's only 1 point available. So if you put both, well done. But just 1 point available. Question 4, this guy looks so like his dad. This is Ice Cube, the guy on the left. So the answer is Ice Cube, and that's his son, O'Shea Jackson Jr. Yes, Krista, I was wondering if some of these were just clones, particularly these two. They look very, very alike. So Ice Cube, the correct answer there. So question 5, this is probably one that you would have recognized because he's quite famous in his own right. So this is the son of Will Smith and Jada Pinkett Smith. That's their son Jaden. So I would accept either Will Smith or Jada Pinkett Smith there. And again, if you got both, good for you, but there's only 1 point available. Okay, on to the daughters. So this is question number 6, and this is the daughter of Meryl Streep. This is her daughter. I don't know quite how to pronounce this, but Mamie Gummer. Mamie Gummer. Look how similar they are. So this is Meryl Streep, correct answer there. Number 7, this one was maybe a little bit not really within the range of knowledge for people who're not really into musicals, but this is the daughter of Bette Midler, who is a legend. So Bette Midler, the answer there, and that's her daughter Sophie von Haselberg. Then number 8, this is the daughter of Susan Sarandon. And I just think it looks so similar in this picture. So that's her daughter, Eva and Muri Martino. Look how beautiful they are. Got great skin, the two of them. Fantastic. So yeah, Susan Sarandon, the answer there. Number 9, I'd be very surprised if anyone didn't get this. This is the daughter of Reese Witherspoon. Pretty much a clone. So this is Ava Philippe. It's just amazing. I really should have got a photo of when Reese was her age and put them next to each other, because that would be weird. But I'm sure you can find that in your own time. So Reese Witherspoon answer there. And finally, who is this guy's mother? And the answer here is Barbara Streisand. And that's her son, Jason Gould. So there's 1 point available there. Barbara Streisand, the answer. Oh, so lovely. Okay. So now it's time to total up your scores. So hopefully you're keeping track. Round 1, round 2, and round 3 are all out of 10. So if you click on the link that we're putting in the chat, click on that. It's a Google form. It will ask you for your team name. So stick that in the top. Then it will say, what was your score in round 1? So if you got 5 out of 10 right, you'll put 5. And then in round 2, if you got 9 out of 10, you'll put 9. And then round 3, if you got 10 out of 10, you'll put 10. Then once you've done that, click through to the next page, because this is where you will click answers to the speed round. So no more need for your pens and paper after this. It's going to be an online form. So I will explain how the speed round is going to work while you're doing that. So in the speed round, every answer is worth 2 points. Now, before now, every answer has been worth 1 point. But for this round, it's going to be 2. So everyone's in it to win it now. Each question will only be read once. So as the name suggests, I will be going through this quite quickly. So listen carefully. I'll only read it once. Once I've read all the questions out, you have 10 seconds to submit your answers. So I advise as you go through, just click and answer. Otherwise, you will run out of time. The first team to submit their answers will get 2 bonus points. And the second team to submit their answers will get 1 bonus point. So need for speed, guys. Okay, so if everyone is ready, make sure you've put in how much you got in each round, your team name. I'm hoping that's given you enough time to get ready for the speed round. I will just give a quick silent 10 seconds while you center yourselves for this round. Okay, everybody, are you ready? Remember, I'm only reading these questions once. They are multiple choice. Question 1. What is the name of the spacecraft observing the sun? Is it A, Soho, B, No, or C, Sono? Question 2. Complete the song lyric. Total eclipse of the A, sun, B, face, or C, heart? Question 3. What calendar did we use before the Gregorian calendar was introduced in 1582? Was it A, the Cleopatrian calendar, B, the Julian calendar, or C, the Roman calendar? Oh dear. Nobody panic. It's an interesting moment. It's okay. You're just getting a free pass for this speed round. Maybe ask my colleague Holly if she has a copy of the slides that she could maybe put up for me. Since internet. Thank you for your patience. In the meantime, I'll take any questions about my dog, who was scratching on the door after I kicked her out earlier, but she's gone a bit quiet now. Fantastic. All right, so we'll just go through. So we've had question 1, we've had question 2, we've had question 3. Okay, here we go. Question 4. The Parker Solar Probe holds the record for being the spacecraft to get closest to the sun. How near to the sun's surface did it get? And here's a hint. The sun is on average 93 million miles away. So did it get to A? You can click on that, Halls. Perfect. A, 3.8 million miles. B, 27 million miles. Or C, 55.2 million miles. Okay, question 5. We've all heard that looking directly at the sun is not advised. But what is the correct name for sunburn of the cornea? Side note, ouch. Is it A, solar keratitis? Is it B, solar keratosis? Or C, actinic keratosis? I knew I was going to get those wrong, even though I practiced. Question 6. In the Jaffa Cake advert that changed our lives, how did the teacher describe this moon phase? Is it A, full moon, B, half moon, or C, total eclipse? Question 7. This is a lovely little sundial, but they can be much bigger. Where in the world is the biggest sundial? Is it A, in India? Is it B, in Australia? Or C, in Russia? Question 8. Which of these edibles is regarded as dangerous by the International Maritime Dangerous Goods Code due to its risk of spontaneous combustion? Is it A, acorns, B, pistachios, or C, sunflower seeds? Question 9. What percentage of creatures living 1,500 feet below sea level are luminous? Is it A, 5%, B, 40%, or C, 90%? And finally, question 10. Humans have long been inspired by great balls of fire. What is the record for longest exploding time for a string of firecrackers? Is it A, 4 hours, B, 16 hours, or C, 22 hours? Okay, you now have 10 seconds. Go, go, go. Okay, that is your 10 seconds up, everybody. I hope that you were up to speed there. Thank you for your patience mid-round. And thank you also to my colleague who has heroically stepped in to save the day. I will now hopefully get my thing back. Fantastic. Okay, everyone. So, question 1, I asked, what is the name of the spacecraft observing the sun? So I want to know if it was A, SOHO, B, NONO, or C, SONO. And the correct answer is A, SOHO. And that stands for Solar and Heliospheric Observatory. So it was launched in December 1995, a joint mission between European Space Agency and NASA. So it was scheduled for just 2 years, but it's actually still in orbit, I think, or at least celebrated its 25 years in December, just gone. So that's pretty impressive. Question number 2, I asked you to complete the song lyric. Total eclipse of the sun, face, or heart. The answer is, of course, the sun. I'm joking. It's the heart. But I seem to have not put the answer in there. It's total eclipse of the heart, which I'm sure all of you know. Okay, question 3. I asked you, what calendar did we use before the Gregorian calendar was introduced in 1582? Was it the Cleopatrian, the Julian, or the Roman? So before Pope Gregory reformed this calendar, the Julian calendar, this was used from 45 BCE, which was introduced by Julius Caesar. There is no such thing as a Cleopatrian calendar, as far as I'm aware. And the Roman calendar was the time before that, which was a complete mess. It started in March, and it had 304 days, so it had 10 months. And then they introduced February, and then January, and every now and then added an extra month. So I think that we're doing quite well with the calendar we have now. So Julian. Question 4. I asked you how close to the surface did this Parker Solar Probe get? So it's held the record for this. So remember that the sun is on average 93 million miles away. And we've actually got pretty close. If you think about it proportionally, we got 3.8 million miles, which is pretty good. That's well within the orbit of Mercury, and more than 7 times closer than any spacecraft went before that. So there was another spacecraft, the Helios 2, which in 1976 came within 27 million miles. One of my colleagues is going to share the NASA article that I was reading about this, which is super interesting, because I can't quite imagine. I'm blown away by space. I think it's really cool. Okay, number 5. I want to know what the correct name was for the sunburn of the cornea. So was it these 3 difficult to pronounce things: solar keratitis, solar keratosis, or actinic keratosis? So I tricked you slightly in that solar keratosis, B, and C, actinic keratosis, are actually the same thing. They're 2 names for the same thing, and that's a skin condition. So the answer here is A, solar keratitis. So that's there with the surface of your eyes, so the cornea becomes inflamed. So the other 2, the same thing. They're a skin condition caused by damage from the sun. If you want to know what else can happen to your eyes, which I'm not going to show a picture of because it's pretty gross, but you can also suffer from solar retinopathy. So that's when UV light literally burns a hole into the retinal tissue. Not ideal. Number 5, I hope everyone remembers this amazing advert. So I want to know if that was full moon, half moon, or total eclipse. It is, of course, full moon. There's a full Jaffa cake there. She then went on to say that this is half moon by eating half of it, and total eclipse by eating the rest of it. Question 7, I asked you where in the world was the biggest sundial? So was it in India, Australia, or Russia? And the answer is it is in India. So it's the Jaipur Observatory, which is the largest and best preserved of the ancient big observatories. And this little image here shows how it sort of works as a sundial, because I couldn't quite figure that out. Question 8, I wanted to know which of these things that you can eat. Acorns? Yeah, I suppose. Are considered dangerous because of the risk of spontaneous combustion. So it might surprise you to know that pistachios are considered dangerous because they have high oil content and they have a tendency to self-heat. So if there was a large quantity of them in cargo, they could experience decomposition, which would result in self-heating and a cargo fire, which is a bit extreme. Question 9, I asked what percentage of creatures living 1,500 feet below sea level are luminous. It is an incredible 90%. Here's an example of a luminous shark. So bioluminescence is the largest source of light in the ocean. So 90% of all creatures who live below 1,500 feet are luminous. Recently, shark researchers discovered a few new bioluminescent sharks. You can read up on that. And finally, I wanted to know what the record was for the longest exploding time for a string of firecrackers. And it was 22 hours. So on New Year's Eve in Hong Kong in 1996, there was a string of firecrackers that went on for 22 hours. So that brings me to the end of the answers, and that just leaves my colleague who is going to bring up the scoreboard from me if she's ready. So when we asked you to put in your scores and then we did your answers to the speed round, we're going to add them all together and we're going to see who is the winner of the solar quiz. And we have run a couple of minutes over. I do apologize. I get a bit too into it when I am discussing trivia that I have found while I was researching various subjects, the sun in this case. Okay, thank you, Holly. So with our final scores, we have, oh wow, so 26 teams. That's incredible. Thank you everyone for tuning in and staying with it. So fantastic. So we have Mononoke. You've got 17 points. Well done. Sunrise, 18 points. The Sweet Corns, 23 points. So you got a bonus point. Well done. You were very fast with that. California Dreamer in 23rd place with 23. That's so lovely. 23 and 23. The Spice Girls, such a great name. 22nd with 26 points. Jarek, you by yourself. Well done. 26 points. Sunshine Rainbows joined there. 26. The Solar Bears with 27 points, along with 19 Crimes and MDWXDLB. I'm sure that stands for something. Dunno got 28. -7 rounders to the nearest integer. I'm sure that's a very funny maths joke with 29 points. Lynch Mob, 29 points. We Screaming, 29 points. You shouldn't be screaming. It does a great job. In 12th place, Tayo with 29 points. Then we're getting to the 30s now. So in 11th place, Sunbeam, beautiful, 30 points. AA Team, powerful, very good. That's 33 points. Then 9, Overqualified, Underperforming. I believe we've had you before. Congratulations. 33 points there. 8, Q-Kiss. I believe that's what it says. 34, well done. Oh, getting near the end now. 7th place, Andy Cowley. Were you by yourself? 35 points. 6th place, Solar Flare, 35. Also joint with the Brightest Stars with 35. Then Dill Space Doze, 36 points in 4th place. We've definitely seen you before as well. Okay, in 3rd place, you've got the Geologist with 37 points. In 2nd place, Florence and Friends with 38. But in 1st place, we have Fun and Games with 40 points. Congratulations. God, a perfect score for the first round as well. And 9 celebrities, children you recognized. And that is an excellent score. I'll have to make the next one a bit harder for you. So thank you very, very much to everyone who took part. I'm afraid there is no prize, but there is glory. I can see we've brought back Reshma and Brian. I hope you enjoyed yourself. So I'm just left to say thank you so much for coming to the quiz tonight, especially if you've been before and you're coming back and you're hearing me talk again. I had fun and I hope you did as well. Our next Imperial Lates Online will center around wildlife. So it's going to be a great quiz, going to be loads of stuff about animals. Maybe my dog will make an appearance. You can check out more details if you go to imperial.ac.uk/what's on and follow us at Imperial Spark on Twitter. We'd also really appreciate it if you could tell us what you thought of tonight's quiz. So you'll see a link pop up into the chat that my colleague will post. Also, just want to say thank you to Reshma and Brian for giving us your time, sharing your research with us, and being wonderful experts. So thank you very much. So all that's left to thank you. So all that's left to say from me is share what you've learned, laugh about what you didn't know. Thank you and goodbye.